Hi everybody, my name is Dr. Noreen Burke and I'm delighted to be joining you today on behalf of the Marine Institute Explorers Education Programme for this special recording for the Cambridge Zero Festival, which is going to look at the basics behind weather and climate and its link to the ocean. Now, before we get stuck into that topic of weather and climate and some of the nice simple activities that we can try out at home or in school, I just want to give you a bit of information about the Marine Institute Explorers Education Programme in case you haven't heard of it before. The programme, which was started in 2006 in Galway in Ireland, now works with over 400 school groups based all around the coastline of Ireland. The idea is really all about celebrating our ocean and bringing it into the classroom. We also work with teachers and pre-service teachers, attend events such as this one, and we have a whole array of beautiful materials which you can find on the Explorers website, explorers.ie. You can see the email address the website address here on the screen, and we'll refer back to that later on as well. So those materials are all freely available for you to download at any time, either at home or in school. Let's get stuck in. So the first thing I like to do when we're looking at this topic is make sure we're all on the same page to begin with, and also give us a chance to explore and wonder. Language is really important. Do we have a good understanding of what these words mean? Where are they the same? Where are they different? Now, I'm going to give you my understanding of these words today, but everyone, you may have slightly different variations, and that's fine. For me, weather is what's happening today, tomorrow, next week, this month, when I stick my nose outside the door. So what are the weather conditions like? Is it sunny and blue skies? Is it raining? Is it windy? Can I feel the raindrops falling on me or hear them landing on my umbrella? Is it stormy and windy or thunder and lightning? Or is there a rainbow in the sky? So for me, weather is something that's on a short-term scale, and it really involves a lot of physical processes, natural processes within our natural world. When I think of climate then, I think of something that's much more longer term. It's like our weather patterns over a long period of time. And when we think of the whole world as a globe, I think of climate as something that is often unique or specific to general geographical areas. So the climate within a region, the climate within the tropics is going to be very different to our climate or our weather patterns that we see, we'll say, in the Arctic or the Antarctic, or the climatic conditions we see maybe at sea level could be very different to an area which is very mountainous and above sea level. So climate is just much bigger scale. So let's bring it back down to that weather first and exploring and wondering. When we think of weather, what do we know already? What are our experiences of weather? If we think of it just on a very stop, breathe, we're standing outside the door right now, what can you hear? Is it windy? Can you hear the wind blowing through the trees? Can you hear the waves maybe crashing against the shore? What can you see? Are you lucky enough to be maybe being surrounded by blue sky at the moment and the sun is shining on your face? Or are you looking at rain clouds and raindrops falling and hitting the ground? And then, of course, they're very much going to impact on how you feel. So can you feel the sun? Can you feel the heat on your skin? Or again, can you feel raindrops hitting off your skin, maybe hitting off your coat or your umbrella? And then those experiences of weather, which I'm going to get you to explore a little bit further in a minute, are they different to maybe your parents' memories or experiences of weather or your grandparents? So when we look at weather patterns, again, now we're getting a bit more now nearly into climate, but those longer periods of time, what are your parents or your grandparents' memories of the seasons? What were summers like, winters like, autumn, spring? Or do you know someone that lives in another part of the world. So are the seasons the same everywhere, or are they different? So let's take a moment to think about our experiences of weather. And if you have an opportunity, this is definitely when you can ask the people you're with in the room, if you're with your family, what are their memories of the hottest day they ever experienced, or maybe the worst thunderstorm they ever saw, or if your grandparents are nearby. This leads us on really nicely to the first explorer's activity, or our first challenge of the day, which is to think about the weather and think about what the seasons look like where you are and whether you think they'll be different in other parts of the world. You might want to look up the weather forecast for today. Did the forecasters get it right? Is it spot on? Or would you be questioning the information they gave you? And then what do the different symbols for weather mean that you often see on the television or you hear about? You might see them in papers and newspaper. So what do all the symbols mean, and do we understand them all? Another nice fun thing you might like to have a go at is like planning out a weather forecast scene. And maybe if you have the technology to make a recording or even like a little podcast, could you do your own weather forecast as if you were the weather forecaster on the telly? Again, could you describe different types of day, different types of weather? So that's your first challenge. Think about the weather today, think about the weather maybe this week, come up with your weather forecast, and then maybe try and present it in a certain way, like on paper, or make a recording, because that's going to be really good fun. Now, once you have finished that first challenge, I want us to think about what might be actually causing these changes in the weather. So when you go outside in the morning and it's windy and it's raining, what's caused that difference to maybe a day last week where it was sunny and blue skies? So what's actually causing all of this to happen? Well, energy and forces is really important, and particularly one type of energy which is coming from the sun. Our sun provides our planet with heat. Heat is a type of energy. That energy interacts with the air in our atmosphere and the water in our oceans to create warm air and warmer water. And as our air and our water warms up, it starts to behave in different ways. So it can affect its density. I sometimes like to describe that almost like its weight, but density is how closely the molecules are all packed together. You have probably noticed changes in density in air if you've ever been near a fire or an open fire and you've seen smoke rising off it. Now, obviously, be careful. Don't get too close to an open fire. We don't want you to get burned. As I said, heat is energy and it can burn you. But if you are standing nicely back from an open fire and you're noticing that the smoke is rising, this is because the air above the fire, as it warms, rises up and the smoke is carried up with it. So what impact does this heat from our sun have on our atmosphere and have on the ocean? And I suppose in the longer term then, what kind of impact does this have on the natural world and where different animals and plants live around our planet? Now, we can do some really nice, very, very simple activities in our kitchens, which will help us explore what happens to water in particular when it gets different amounts of this energy. For these activities, I used sunny days and also days in wintertime when it got really, really cold outside and there was very little of that heat energy from the sun, particularly overnight while the sun wasn't shining in my garden. So what I have here is a water cycle in a bag. This is definitely something you can try out if you have a window in your home where you can stick this bag where it's going to get the sun's energy shining onto it. What we've got is a Ziploc bag, which we've put a small amount of water in. And when we've stuck it up on the window, we've put it at an angle. So our water is down in one corner. And when you stick it up and you leave it there over a couple of days, what you'll notice is the sun's energy causes some of our water in our bag to evaporate. So that means it turns it into almost like, steam. It travels up the bag, up towards the top of the bag, and then it settles on the top of the bag where it condenses again. So our water droplets form again. And then eventually, after a couple of days, if you rub your fingers at the top of the bag, you can create your own little patch of rain or precipitation. So these are all words that get used in our water cycle. Evaporation, precipitation, and accumulation is when the water gathers together again, like we'd see in our rivers and streams. Other activities then that you can see here, I've got a tray of just some hot water, which I can see the steam coming off of. I have a tray that just has some salt in the bottom, and how I managed to get that one was I put some salty water in a silver aluminium tray that had been in my recycle bin. I left it in a sunny area in my house, and the sun's energy evaporated the water, leaving just the lovely salt crystals behind. Now, the opposite to all that heat is definitely cold, and I made a lovely ice sculpture in my garden as well last winter when I was able to put some water in a tray with little twigs and leaves and berries and let the cold freeze it. So I had this lovely block of ice. So very, very simple activities that you can definitely try out in your kitchen. So this is your second challenge, to see the impact of the sun's energy, the heat coming from the sun on water by experimenting with it just in your kitchen or in a window in your home. Now, the next thing we're going to have a look at is we're going to have a look at ocean currents in action. And again, this is a simple activity that you should be able to try at home. It does involve some hot water, so be careful. Ask an adult if there's one there with you to maybe give you a hand. I have put some warm water in a flask the day I did this. You could get some warm water out of the tap. Just make sure it's not too hot because again, we want to be careful and for you not to get burnt or injured in any way. The other piece of equipment you'll need is maybe like a large jug, a large bowl, a source of cold water as well. And what does come in very handy for this activity is a little bit of food colouring. It doesn't really matter which colour you use. I used red in this activity, but you could use any colour because it'll help you to be able to see the different types of water. So we're going to get our equipment together and we'll start I think this is probably our third challenge. We're going to have a look at ocean currents in action.
So what we're going to do is we're going to get our warm water here and we're going to fill our little container with some of this warm water. And I'm just going to do this over this so that if any spills, I won't get it all over the table and all over myself. Okay, so you can see the steam coming off it there, hopefully, in the film. So you'll know that it's hot water. Brilliant. And I haven't filled it up completely to the top. I'm just going to put my jar down here for a minute. I'm going to put my lid back on my flask again, just to save any accidents happening. And I'm going to get that food colouring. I'm going to pick red because this is hot water. So red can represent the heat. And I'm going to get my pipette, which will help me to get some of the food colouring out. Okay. Maybe just one more little bit. Soak it up and into the jar. Okay, right. I'll just put the rest back in there. Put this here and put the lid on the food colouring because there's nothing worse than spilling a bottle of food colouring. So, as I said, here's my container of nice cool water. Yeah, nice and cold. Here I've got my little jar of warm water. Now, if these two types of water are exactly the same density almost like the same weight because the molecules are positioned the same in both, then when I put this jar into here, the water shouldn't come out of it because they'll both be the same. The same way if I put the little jar in and this is kind of heavier or denser because the molecules are more closely packed together, it shouldn't come out because it'll want to stay in the jar. But when I put this little red jar in here, if the warm water is less dense, we might describe that, I suppose, as lighter. If the molecules are further apart, then this water should come out and float on top. So I'm hoping now that you can see this. Here's my jar. I'm going to put my little red jar into it. Place it down, and I'm going to take away my hand, and hopefully now you will be able to see the red starting to come out and form a layer there on the top. Wonder if I just put this sheet of white paper behind it might help you to see as well. So our red water here is coming out of the little jar, and it's forming a layer of red warm water on the surface. And that is because warm water is less dense. So water at the tropics and at the equator warms up and is at the surface of the ocean, and it pushes water out of the way and it begins our ocean current. And then as our water gets to the Arctic and the Antarctic and it's cooling down, it sinks and pushes water out of the way. So this density difference between warm and cold is what causes our ocean currents, or one of the reasons for our ocean currents. So it's incredible to watch. Now, the other thing we mentioned is, the effect of a changing climate on our water. Obviously, warmer water can actually carry less nutrients than the colder water that's underneath. So that's going to affect the animals and the plants that live in it. And also some of our animals and our plants that live in the ocean, they like to live in certain temperatures of water. So water that is too warm will mean maybe they can't live in it anymore, and they might be able to change where they live, so they might be able to move to a different part of the ocean. But depending on how mobile they are or how easily they can move, this may affect them. Now, again, I'm not sure if you can see it, but my warm water is now starting to cool, and I'm getting these lovely little lines of warm water starting to sink down as the water mixes and the warm water cools down.
Okay, so I hope you enjoyed that. I hope you enjoyed watching it. And if you stopped the video and you had a go at trying that at home, I hope it went well for you and it didn't create too much of a mess in the kitchen as well. I really liked that experiment, and do try playing around with maybe different theories or hypotheses. So we looked at how hot water came out of your little jar, but maybe try next time having warm water in the main container and putting in a little jar of cold water. And you can try maybe then seeing if that comes out, or if there's a different result, or do you need to tip the jar over next time. You can try looking at salt and fresh water as well to look at these changes in density or differences in density. So it's all about good science, hands-on fun, and just having a play in the kitchen. So the full lesson plan for that is on the Explorers website, if you do want to read more detail about it. And another thing is, if you don't get to actually do that experiment with the water, you only got to watch it today, you can just look at weather around different parts of the planet. So such as like, what's the weather forecast like today in Ireland and England versus what's the weather forecast in Canada, and you can compare the differences and just see the impact really of that Gulf Stream, that warm water current that's flowing across the Atlantic Ocean past us over here on the Eastern Atlantic. So the next thing we're going to have a look at then is just thinking about, where do scientists get some of this information from? If I'm a scientist and I want to monitor the weather, I want to monitor our climate, and I want to monitor the ocean, one of the things I might use are things like satellites, Argo floats, and weather buoys. And we're going to have a bit of drawing fun next, because we've done some learning and exploring. We've done some science, hands-on activities, and now it's time to maybe get a pen and paper, or pencil and paper, I should say, and we are going to join Dr. John Joyce as he shows us how to draw a weather buoy, a satellite, and an Argo float, and he's going to give us some really cool facts and information along the way. So pause the video for a second, go grab a piece of paper and a pencil or a notepad or the back of something to draw on, and let's join John as he shows us how to do some drawing in our Explorers See How to Draw video.
Welcome to the See How to Draw classes. Today, the amazing cartoonist and author John Joyce is going to show us how to draw a data buoy, Argo float and satellite.
Now I'd like to show you how to draw 3 bits of technology that the Marine Institute uses to measure things in the sea: the temperature, the currents, the amount of salt in the water. The first one of these is called the data buoy, and this has a big float at the bottom, like a big metal can. And then on top of that, there's all sorts of instrumentation, and underneath it there are things that measure current and the amount of salt in the sea and so on. And it's powered by solar energy, so it has solar panels on either side. And on top it's got all sorts of instruments which are protected by a metal frame. There we go. And that goes around the back there so you can see it from the front. So it's got what they call an anemometer, which measures the wind speed. There it is, has a propeller on it to measure the wind speed. And a navigation warning light. And let's put the solar panels in, because it's powered by energy from the sun, so you don't have to keep restocking batteries. It's very clever, isn't it? And here's a technician who's come to make sure that it's in good working order. There's a big smile. There he goes. And he has a protective hat. There it is, for safety. A bit of hair as well. That's my eyebrows. And of course, again for safety, he's wearing a life jacket. And he's hanging on with this hand to the framework underneath. It goes down there. And because he's a happy man, enjoys his job, he's giving us a big wave. There. Now, that piece of equipment is sending information back to the Marine Institute through a satellite. So let's put the satellite way up in space, up here. I'll give it a pair of eyes because it's a cartoon character. There we go. And it too is powered by solar energy. So let's put the solar panels in. And the satellite's got all sorts of equipment on board for taking in radio waves and measuring things from space. We can even measure the temperature of the oceans on the surface from space as well. So that's collecting all the information from all over the place about the ocean that's supplied by these buoys underneath. There. Now if you want to know about the deep oceans, you need another piece of equipment which is called an Argo Float, and these Argo Floats actually sink right down into the depths of the ocean, and they measure things as they go. Again, like temperature and the amount of salt in the water as they go down deeper and deeper and deeper, and then come back up. They give the information back to the Marine Institute. There we go. It's got little fins on it. And that's an Argo float, and that sinks down into the water. There. So we've got the data buoy giving information to a satellite, and the Argo float giving information to the satellite, and the satellite sending the information back to the Marine Institute.
So, after all that drawing with John, let's see what we have learned today about data buoys, Argo floats and satellites. Thanks for drawing with us today. See you next time.
So how did those drawings go? Wasn't John fantastic? I really enjoy that mixture of like drawing and learning at the same time. It's fantastic. And I hope you learned a little bit more about satellites and Argo floats as well. So all this amazing technology which has developed over the last couple of 100 years really helps scientists now to monitor and hopefully help us care for our ocean. Our ocean has been changing as our weather and climate does. It's been absorbing more heat, it's been absorbing more carbon dioxide, and that has led on to things like seeing sea levels rise, sea temperatures rise, and you might have heard of a term called ocean acidification, which is where the pH of our ocean is changing as well. Now, more than ever, it is incredibly important for us to understand our weather, understand our climate patterns over time, and how they change. And then that link between us, I suppose, now and humans and climate, and humans and the natural world. So I hope you enjoyed today's session, which looked at the basics of weather and climate and some activities that you can try out at home. Remember that you can get lots of fully available and downloadable materials from the Marine Institute Explorers Education Programme website, including a whole range of wonderful short films on squid, on the seashore, on see how to draw, and lots of fantastic student workbooks as well that you can download to use at home or in school. If you want to connect with us on social media, we're also on Facebook and Twitter. So enjoy the rest of the Cambridge Festival, and remember from us all here at the Explorers Education Programme, keep exploring.